All right, so we're done with the complicated stuff. Let me go back to only having one file, and let me actually throw out this entire example. We're not gonna need it anymore, right? So we're gonna do just print line hello world. Okay, so we're just gonna go through a list of details that that are relevant to the topic of error handling and exception. The first thing that you need to know is that exceptions can be nested. So if we go to the API, this one, so this is a Java API for the class exception, right? So it extends throwable, and it extends which extends object, right? And it has a bunch of constructors. So there are many ways to construct an exception. There's a way where you just give it a message. There's a way that you give it a message and you give it another throwable, right? Or there's also a simple one where you basically just end up nesting exceptions. Let's do that. In fact, we don't even need to do that, because I forgot that we can just go back a little bit, right? This is exactly what happened over here, right? So we caught the exception, right? And then we were throwing another exception, right? But what we can do is we can throw our own exception, right? We can say throw new, for example, runtime exception, right? And then in the constructor we can pass in the e, and what we will see is the whole stack trace. So you see the runtime exception, which is the one that we threw later. It's at the top, and then at the bottom you see caused by error, not enough disk space, which is kind of unfortunate, because what happens in production, in practice, is that you end up with those gigantic stack traces. You have a bunch of code, and only in the very, very bottom it says caused by. Kind of not ideal, but something that you have to know. Okay, so let me actually go. I have to remove the whole code again manually. Let me do this like this. I think that was one too much. This print line hello world. Right, okay, so we're back to square one. The next thing is all the things that you need to know about null. So we're gonna have print line null equals null. I'm starting to lose my voice again. This means that the video is too long. Right, equals null. Sorry, we're also gonna have print line null not equals to null. We're also gonna have print line null as instance of any. Let me remove the cursor. And we're also gonna have is instance of any. Right, so all of these, they don't throw exceptions. Sorry, this is called NE, not NEQ, right? So they don't throw exceptions, they just produce some warnings, right? But everything compiles, everything runs. Okay, however, these ones, null equals null, this one does throw an exception. Remember in the video about equality, I said that the double equals symbol method always just delegates to equals. Well, it doesn't just delegates to equals, it also includes a null check. So it does a null check, and if that's false, only then it redirects to delegates to equals, right? So you can't do this. Basically, never call equals directly in Scala, right? This is a Java thing. Okay, so we're gonna have null toString. It's gonna throw an exception again. In fact, maybe let's remove these like this. Okay. All right. The same with null dot hash code. I'm just gonna save it, and it's gonna throw an exception. I'm gonna comment it out. I'm gonna go with null get class C, capital C, get class. Right. It's also gonna throw an exception. Let's talk about this one a little bit. So if we do this, right, if we do val str equals null to string, right, and now if you do val str equals string, the companion object of string, it has a method called value of, and now if you give it null, then hold on, let me do this one first. So this one throws an exception, right? This one also throws an exception, and which is most important, if you do something like string value of null, but you use a type description, right? So if you say that this is a person, for example, right? Let's have a final case class person, which has, I don't know, a name string age int, right? Then it will actually produce an empty string, right? So not an empty string, sorry, it's going to produce a null string, right? So look at this. This one throws an exception, right? Let me show it again. But so basically it's just a like an extra thing. If it recognizes the literal, then it throws the exception. But if it's anything else, then it's actually fine. So this is sometimes it depends on the application that you're writing, but this is a very useful method to know about. Okay, the next thing is going to be option. So now.get obviously throws an exception, as we already figured out. It should actually be sort of removed from the language. Option.empty.get, same thing, doesn't matter which type, it's empty, so it's going to throw an exception. In this case, a Java util no such element exception, right? The next thing is print line sum of null. So now options are sort of there to guard you against null, but you still can end up with a sum of null. Therefore, it is sometimes advised to use an option, right? So an option of null is actually going to produce a none if it's a null, right? So it's just a different constructor. The next thing are some helpers. So there are some helpers just floating around that can throw exceptions for you. So you can just say require 1 = 1. So you just pass it in a boolean, right? And then everything is fine. And if you say 1 = 2, then it actually throws a illegal argument exception, requirement failed. And you can also pass it a message. So you can say 1 was not 2, right? Then it's going to say failed, 1 was not 2. Okay. What you can also do is you can say assume. Let me comment this out. You can assume 1 = 2. They're all doing the same thing. They're just throwing a different exception, right? So before it was an illegal argument exception. Over here it says assertion error, right? Assumption failed. And I believe you can also give it a 1 was not 2 message. Yeah, I'm sure you can give it to all of them, right? Let me remove that. So we have assume. We also have assert. 1 = 2, and there's sort of two ways to write assert. There's one like this, and there's one that you can sort of write at the back. So there's one like this. You can do 1 = 2, and then on any expression you can say ensuring, which takes in a lambda. So you say, okay, whatever came out of this, which in this case is a boolean, if it's true, then just return it, otherwise throw an exception. So it throws exactly the same exception as the assertion. In fact, for this one, I'm going to have a better example so that you understand why the hell somebody would invent something like this. So if you have a method like this, fancy logic, and it gets in a number, which is an integer, produces another integer, and it's doing something like number plus, some really fancy logic, number plus int max value, which in math it should always be a positive number. So what you can do is you can say ensuring that whatever comes out is greater than 0, right? So now you can print out 1 plus int dot max value. In fact, let me do 1 + 2. 1 + 2. Forgot to call it fancy logic. Fancy logic 1 + 2, like this, then everything is fine. Or actually, why am I calling it was 1 + 2? Let me call it was a 0, because 0 is basically the only, not the only, but if we call it was a 0, then it's like the last positive number possible, right? But as soon as we call it was a 1, then it's going to overflow, right? And then this ensuring, it's going to throw the assertion failed exception, right? So this is just like sort of like a convenient syntax, right? So you can also do it like without the curly braces, right? So usually what you will have is you will have some expression like this, and then you will have dot ensuring, which is a high order function, just takes this, right? So still the same effect. All right, the next basically the last helper with this is sys.error. So instead of saying throw new runtime exception with a message called boom, right, which is going to look like this, we can also do a shorter version. We can do sys.error boom, right? Does exactly the same thing. There's another one on sys called sysexit, which does completely something different. So this one is going to kill your application, and it's not going to use the concept of exceptions to do that. It's a very special signal, right? So if you do 0, then it's just going to say, hey, application finished. Trap access security exception, blah, blah, blah. But this is the one that SPT is doing. If it's -1, then you're going to see, this non-zero exit code, -1 in this case, or it can also be +1, as long as it's not a 0. So the thing is that what is being used behind the scenes is not exceptions, right? So if you try to catch it, it doesn't matter how hard you're gonna try, So if you're gonna do catch case e, even if you do the whole throwable thing, right? Let's do print line e. In fact, let's not print line e. We can do show rad e, right? And we can also do finally print line. Finally always happens, and after that we're gonna see print line not gonna happen, right? So even though we're catching this exception, exceptions have also a method called getMessage, right? So we need to pass in a string, right? So finally always happens, but even though we're catching all the possible exceptions, we're still not able to restore the normal control flow, right? So we don't see this. So the concept behind this is something completely different. It's a special signal that signals the JVM that it should shut down. Okay. The next thing that we're going to talk about is what is happening if the exception is not handled anywhere. And the thing is that there is, for every thread, there's like this last measure. There's like this handler, right? And we can actually take a look at it. So what we can do is we can say def handle, right? Which is a function that takes in a thread and a throwable and produces a unit, and we can say equals, right? And it equals to a thread, which is a companion object for the thread. We can use the current thread, so we can getting the current thread up. We can say get uncaught exception handler, right? And we can call on it the uncaught exception, and the add expansion is going to convert this into a function thread throwable unit, right? So what we can do now is we can handle so we're going to give it the current thread, and we're going to give it the system error, boom, right? Now actually we can't do this. We have to give it the exception. We can't throw it. That's what's happening here. We have to give it a new runtime exception, because what was happening was that it was getting thrown, right? So if we do this, right, then we just see, you know, the default handling of the exception. We see the stack trace, right, but the application finished normally. However, if we actually throw this, so we're gonna see the same stack trace, right, but now the application actually died. So what we can do, which is kind of funny, we can define our own handler, right? So we can have a global handler, right, which has a type of thread uncaught exception handler, which is, by the way, something that this returns, and we talked about SEM types before. I'm sorry, this one. So the type of this is thread.uncaught exception handler, right? So we can have a global handler like this. We can do the thread, the throwable thing, right? And now we can use our fancy our fancy show red method, right, that takes in the string interpolation, and we're going to do \n, right? So we're going to do like an empty line, and over here we're going to do throwable, and we're going to do throwable.get message. Let me make some sublime real quick. Throwable get message on thread, and we're going to do thread dot get name, so we can get the name of our thread, right? So we have this global handler, and now all we need to do is we need to register this handler, right? So let's do this. Let's not throw this exception for now. Let's just handle it, right? Then let me maximize it. It jumps around. I hate it, right? So we're gonna handle the thing, right? Then we're going to set a different exception handler, right? Current thread. Now we're gonna say set uncaught exception handler, and we're gonna give it this global handler that we just created, right? And now we're gonna handle again. So the first time it's going to do the same thing, but the second one, it is going to use our exception handler. So this means that if we basically, after we register it, if we actually throw an exception, we're still going to see our exception handler. By the way, there are also methods get and set the default uncaught exception handler, but I had problems with them, so I decided not to include them in here. And by the way, we don't need this person anymore here, right? And the last thing about this is, as you can see, you can do it on any thread. So originally I prepared an example where I would create a thread and do the same thing for this other thread, but I'm basically running out of time. This video is way too long. I'm probably gonna split it into parts anyway. The next thing that we're gonna talk about is that there's a problem with threads, is that the exceptions are sort of local to those threads. So if one thread wanted to communicate the fact that something went wrong to another thread, you would need to build some custom things and use bars everywhere and stuff. So there's a concept for this called try, right? So it's just a simple algebraic data type which is there to handle the exception. So what you can do is, the first thing is it lives in scala.util, and I believe the next video is going to be about packages and imports. So what you can do is you can calculate the result, and the result is going to be a try of, in our case, it's going to be a string, right? So you can handle the exceptions by using the capital try, like this, right? So now if you do system.error, boom, and over here you can just match on it. There are different ways to deal with it, but basically it's a simple algebraic data type, very similar to option. It has a case success, which gives you a value, which in this case is just a string. So we're going to do a show green value, and if it's a failure, and they both leave in scala.util, all right, if it's a failure, then it's going to give you a throwable, and then you can do show red throwable get message, for example, right? So in this case, it's gonna, show the boom, and in the other way, it's just gonna show you the string, like everything went fine, right? So now it's green. The other way around is red. So there are many ways to work with tries. One of them, for example, so instead of pattern matching over here, what you could do is you could say print line result get or else no worries. Right. So now, if it returns this, then you're still going to see this, and otherwise you're going to see, boom, right? So no worries. And then use print line. So I should have used, show green, right? So you see no worries in green now, right? Also, you can convert it to an option. So you can say val optional, which is an option of string. So now you can take your result and just convert it to option. And option, the options also have the get or else method, right? So you can also use optional here. So it's basically exactly the same code. There's also another alternative called scala.util.control.Exception. Let me actually show it to you over here. Yeah, so it's over here, scala.util.control.Exception, just a companion object for exception, and it has a bunch of useful things. So you can go through this in your own pace and look at this. I'm just going to show you a small example. So what we can do is we can say, so instead of all of this, what we can do is while result equals, we could, for example, say catching. Oh, by the way, we need to import it. So instead of importing scala.util, let's import both. We can import scala control, or was it util? Was it util? Yeah, it was util. Scala.util. So now we can actually, I'm going to do the full import scala.util.control, because we haven't talked about imports yet, so I don't want to confuse you, right? So we can import this, and now we can use catching, which is a def defined on this object. We can do catching, and then we can say class of, and in this case it's going to be the runtime exception. So if it's a runtime exception, then we can, for example, say then return an option, right? And then we give it the code, right? So if it throws an exception, right, like this, boom, then we can see result dot, I'm going to do get class, right? So in this case, it's going to return an option, right? What we can also do is we can do with try, right? And there's also another one called either or either, depending on where you come from. It's a very similar algebraic data type, but it in its core it doesn't have anything to do with exceptions. But it is usually, it's very common for it to use for error handling, because it basically has the left case class and the right case class, and usually the right case class is the right and the left one is used for exceptions. So you can do either, and now we're going to see scala.util left in this case. And if we return, for example, some other string, something actually valuable, then we will see the right. So now it's the right one. There are also many other alternatives. There are other libraries. One of my favorite ones, for example, called scalactic. It comes with a bunch of things, and one of the things that it comes with is validation, right? So what you can do is, hold up. Let me see. So you can do something like this, parse h, and then you do your regular try catch, and then you return, instead of left or right, or instead of some or none, or success or failure, you return good and bad, right? Or you use this cool way of defining the type. You can say person, or give me like an every error message, and then you can look at this at your own place. The link is scalactic.org, and I'm going to include all the links in the description anyway. So you can combine basically exception. You can, like when you're filling out the form, then it can give you all the arrows and then just one, for example, things like this. It's really cool. let's go back to our code. The last thing that I'm going to show you today is a thing called NonFatal, which is an extractor object for exceptions. You might end up seeing this when you're reading Scala code from someone else. So if you look at NonFatal, it is basically, it lives in Scala control, scala.util control, right? It's just an object, it's just an extractor. We already talked about extractors in the previous video, actually. So if it matches one of those exceptions, it considers them fatal, and therefore it says false. So it doesn't match on them. So if it encounters a fatal exception, then it throws it again, basically, right? You might be wondering why you would use it. Actually, let me show you first how you would use it. So you would go and you would say try sys.error, boom, okay? Then you would say catch, and it's a simple extractor, right? So you're gonna say non-fatal was an E, right? And then you're gonna say show red E dot get message. Doesn't it live there? I think it lives in scala.util.control, scala.util.control. We just looked at it. Yeah, scala.util.control, right? Okay, so because this throws a regular runtime exception, it is a non-fatal exception, right? But if we try to throw, for example, a throw new Java long interrupted exception. I'm not sure if it's in Java long actually. Yeah, it is, right? So see, now we didn't see this red, right? So it is not defined for the interrupted exception. Now you might be wondering, why do we need this, right? Because we already said, okay, there is throwable and there is exceptions and there is errors. So the errors are the one that we shouldn't handle anyway, right? So why isn't it enough to match an exception? The thing is that some exceptions, some that are not errors, they are actually kind of fatal, like this one. This interrupted exception, if we look at the API, over here, it is actually not an error, right? It extends exception, right? So non-fatal helps with that, right? So it's defined over here, right? So it's gonna rethrow it. All right, that's most of the things that you need to know about exceptions. Now you're the local expert of, about the exceptions. Choosing which technique to use, usually, first of all, it depends on the use case. Second of all, it depends on the style that your team has chosen. So basically, always evaluate, your use case and talk to your team. And if you're still in doubt, then try to avoid exception. Start with a type-safe solution, and only introduce the more convenient one later. All right. It's been Vlad, devinside.com. Like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.